Hello, how are you? Today we are going to learn integration by substitution method. I hope you already gone through my previous videos on integration. If not, please go through them first, then watch this video. Today I am going to solve ample of problems. Integration by substitution method. Sometimes the given integration problem is not in the standard form. To convert into the standard form, we use substitution method. Example, this problem is not in the standard form. Now we can convert into the standard form by using some substitution. So let us call the given problem I equals to and call it as the equation number 1. Now let root x equals to t. Why we are doing this one? So that the given problem which is not in the standard form, we can convert into the standard form by putting some suitable substitution. Example, root x equals to t. And as soon as you put substitution, you have to do the derivative. So differentiation of root x with respect to x equals to dt by dx. And root x equals to t, let us call it as a second number. Now derivative of root x is nothing but 1 upon 2 root x with respect to x equals to dt. Now what is the given problem? The given problem nothing but I equals to integration sine root x, which can be written as sine root x multiplied by 1 upon 2 root x and dx. This is nothing but equation number 1. Now 1 upon 2 root x dx can be replaced by dt because 1 upon 2 root x dx nothing but equal to dt, and this root x can be replaced by t. Therefore given problem is converted to sine t and dt. Now this has been converted into suitable form, and the problem has converted from one variable to another variable. Originally the variable was x, now the variable t. So the question has converted from one variable to another variable. So integration of sine t with respect to t, nothing but minus cos t plus c. But what is the t? T nothing but root x. So back substitution. Therefore I equals to minus cos root x plus c. This is required solution. This way of integration is nothing but called integration by substitution method. In substitution method, it is very important that the derivative of one of the part is available in some other part of the given question. Example, e raised to 4x. The derivative of e raised to 4x is e raised to 4x itself. It is available in some other part of the problem. You see, in denominator e raised to 4x is there. In numerator also e raised to 4x is there. Therefore, before start doing the problem, you decide what is t. The problem quite lengthy, but there is only one function which can be equals to the t. Example, here let e raised to 4x plus 1 equals to t. Why I selected this? I have selected this because derivative of this part is available in the other corner of the problem. And moreover, the given question is always equation 1 and this is the equation 2. Now after that, doing derivative e raised to 4x plus 1 with respect to x equals to dt by dx. After doing this one, what is the derivative of e raised to 4x? 4 e raised to 4x equals to dt by dx. Now we have to keep only things which are there in the question and other constant to the right side. Example, e raised to 4x and dx we kept left side and the constant is taken to the right side. So e raised to 4x dx equals to dt by 4. Now the given question, what is the given question? The given question is integration of e raised to 4x upon root e raised to 4x plus 1 with respect to x. So the given question can be written as 1 upon root e raised to 4x plus 1 into e raised to 4x dx. Now e raised to 4x dx equivalent to dt by 4 and let us call it as a 3 number. Now e raised to 4x dx nothing but equals to dt by 4, and e raised to 4x plus 1 nothing but equal to t. Therefore, the problem has been converted from one variable to another variable, that is I equals to 1 upon root t into e raised to 4x dx is equivalent to dt by 4. So I equals to 1 upon 4 integration 1 upon root t dt. Now after that we can do the integration. Now integration not yet started, only the pre-preparation is going on, because the problem was not in the standard form, so we converted into the standard form first. Now we have to do integration. Even this situation it is not standard form, because 1 upon root t, we don't have formula for 1 upon root t, so we have to convert into the suitable standard form. So in place of the root t I can write t raised to 1 by 2 dt. After that I equals to 1 upon 4 t raised to minus 1 by 2 dt, because 1 upon t raised to 1 by 2 can be written as t raised to minus 1 by 2 dt. Now we can apply the formula integration of x raised to n nothing but x raised to n plus 1 upon n plus 1 plus c. This formula we can apply here. Therefore I equals to 1 upon 4 t raised to minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. This is equals to 1 upon 4 t raised to 1 by 2 divided by 1 by 2. So I equals to 1 upon 4 into 2 upon 1 into root t. 2 ones are 2 twos are get cancelled. Therefore it is root t upon 2. What is t? T nothing but what? E raised to 4x. E raised to 4x plus 1. That was the t value. So what is the final answer? Under root of e raised to 4x plus 1 upon 2 plus c. This is required solution. Example 3. Integration of 1 plus log x whole raised to 5 upon x with respect to x. We have to find the integration of this. And what is the substitution? There are the two, one is the numerator part, another is the denominator part. Of course, the derivative of x is not going to be the log x, but the derivative of log x is going to be x. Therefore, let 1 plus log x equals to t. We have made the substitution. This one, given problem is 1 and this is the 2, and after that differentiating with respect to x, differentiation of 1 plus log x with respect to x equals to dt by dx. Derivative of 1 is 0 and derivative of log x is 1 upon x equals to dt by dx. Therefore 1 upon x equals to dt by dx. Therefore 1 upon x dx equals to dt. Call it as a number 3. Now the given problem can be written as I equals to integration of 1 plus log x whole raised to 5 into 1 upon x dx. Now 1 upon dx is nothing but dt, and 1 plus log x nothing but equals to t. Therefore the given question is now converted into standard form by putting 1 plus log x equals to t, so it becomes t raised to 5 and 1 upon x dx equals to dt. Now the given question has been standardized. We brought into the standard form. After the standard form, integration of t raised to 5 nothing but t raised to 5 plus 1 upon 5 plus 1 plus c, that is equals to t raised to 6 upon 6 plus c. What is t value? T value nothing but 1 plus log x, so it is 1 plus log x whole raised to 6 upon 6 plus c. So this is the solution. Next question, evaluate integration of x plus 1 into x plus log x whole raised to 5 upon x. Here, what is the substitution? Of course, the derivative of x is not going to be the log x, but derivative of log x is going to be 1 upon x. So we try here. Sometimes we have to do one or two options open If one option is not working, you have to go for the second option. So first option, x plus log x equals to t. Generally by observation, we get the easy guess that this can be the t. So x plus log x equals to t. Now differentiating with respect to x. So derivative of x plus log x with respect to x equals to dt by dx. So derivative of x is 1 and derivative of log x is 1 upon x equals to dt by dx. So x plus 1 upon x equals to dt by dx, which can be written as x plus 1 upon x dx equals to dt. So this was the given question is 1 and this is a 2 and this is a 3. Putting 2 and 3 in equation 1, put 2 and 3 in 1, so we get I equals to, now the given problem can be written as x plus log x whole raised to 5 as a one part of the question, x plus 1 upon x dx as the second part of the question. Now x plus 1 upon x dx is equivalent to dt, and this x plus log x nothing but t, so it is a t raised to 5, and x plus 1 upon x ds equivalent to dt. This is the integration of t raised to 5 is nothing but t raised to 6 upon 6. Here the problem was not in the standard form, we converted into the standard form by substitution. So substitution method is to get standard form. So we got here t raised to 6 upon 6. What is the t value? T value nothing but x plus log x, and what is the power? 6 upon 6 plus c. This is required solution for given integration problem. Example 5, evaluate integration of 1 upon 1 plus e raised to minus 3x with respect to x. Sometime what happened? The question seems to be not under the substitution method but on simplification, but on algebraic simplification it becomes suitable for substitution method. For example, here the given question can be simplified algebraically first, after that we will be doing integration. First of all, we go for algebraic simplification, that is 1 plus e raised to minus 3x can be written as 1 upon 1 plus 1 upon e raised to 3x, that is equals to e raised to 3x upon e raised to 3x plus 1. Therefore, integration of 1 upon 1 plus e raised to minus 3x with respect to x is equivalent to integration e raised to 3x upon e raised to 3x plus 1 with respect to x. Let e raised to 3x plus 1 equals to t. So derivative of e raised to 3x plus 1 with respect to x equals to dt by dx. After that, the derivative of e raised to 3x is nothing but 3 e raised to 3x equals to dt by dx. Therefore, e raised to 3x dx is equal to dt upon 3. Now, this given question was 1 and this was the 2 and this was the 3. Now, this was the 3. Now, from 2 and 3, put 2 and 3 in 1, put 2 and 3 in 1, we get I equals to, first of all, I can be written as 1 upon e raised to 3x plus 1 multiplied by e raised to 3x dx. Now I equals to 1 upon e raised to 3x plus 1, e raised to 3x plus 1 nothing but t from 2, and e raised to 3x dx. This much part is equal to dt by 3, so it is dt by 3. After that, we will be doing integration. So I equals to integration of 1 upon t nothing but log of modulus t divided by 3 plus c. So what is t? T nothing but e raised to 3x plus 1. So log of modulus of e raised to 3x plus 1 upon 3 plus c. This is required solution. Example 6. Evaluate root tan x into sec square x with respect to x. Here the derivative of tan x is sec square x, but derivative of sec square x not equal to tan x. Therefore, first of all, let root tan x into sec square x dx as the equation number 1. After that, let tan x equals to t differentiating with respect to x, differentiation of tan x with respect to x equals to dt by dx. Till now, you might have got an idea that in substitution method, as soon as we put t, we have to do the differentiation. So here derivative of tan x with respect to x equals to dt by dx. Derivative of tan x nothing but sec square x equals to dt by dx. This can be written as sec square x dx equals to dt. Call it as the equation number. It is the equation number 2 and this is the 3. Now putting 2 and 3 in 1, put 2 and 3 in 1. So we get I equals to, now in place of tan x put t here, and in place of sec square x dx we write dt here. So this becomes integration of t raised to 1 by 2 with respect to t. Integration of t raised to 1 by 2 nothing but 1 by 2 plus 1 upon 1 by 2 plus 1, that is t raised to 3 by 2 upon 3 by 2. Therefore I equals to 2 by 3 t raised to 3 by 2. But what is t? T nothing but tan x. Therefore 2 by 3, here is a tan x raised to 3 by 2. Of course plus is there. Therefore what is the final answer? The final answer nothing but I equals to 2 upon 3 tan raised to 3 by 2 plus c. This is required answer. Example 7. Evaluate integration of sec raised to 7x into tan x with respect to x. Now, whenever tan x and sec x got multiplied, then it becomes a quite easy problem, because derivative of sec x nothing but sec x into tan x. So, of course, this is a very quite easy problem. Let us solve it. So, step number 1, let I equals to sec raised to 7x into tan x with respect to x. Equation number 1, whenever sec x and tan x given in the question, and if they are multiplied, then you can separate like this. Sec raised to 7 can be written as sec raised to 6x into sec x into tan x with respect to x, because you know that the derivative of sec x is nothing but sec x into tan x. So call it as equation number 1. Now let sec x equals to t. Now differentiating with respect to x, so differentiation of sec x with respect to x equals to dt by dx. Derivative of sec x is nothing but sec x into tan x equals to dt by dx. Therefore sec x into tan x with respect to x equals to dt. Now I equals to, here the sec raised to 6x, this was the, of course this was the 2 and 3. As usual, putting 2 and 3 in 1, we get I equals to t raised to 6 and sec x tan x dx is equal to dt. So now the given question is converted into standard form. After that, integration of t raised to 6 nothing but t raised to 7 upon 7. What is the t value? T value sec x. So sec x raised to 7 upon 7, which can also be written as sec raised to 7x upon 7 plus c. This is required solution. Evaluate integration of sin inverse x whole raised to 5 upon under root of 1 minus x square. Solution. We know that the derivative of sin inverse x is equals to 1 upon under root of 1 minus x square. The given question can be written as I equals to sin inverse x whole raised to 5 into 1 upon under root of 1 minus x square with respect to x. Let sin inverse x equals to t, because derivative of sin inverse x nothing but 1 upon under root of 1 minus x square. So differentiating with respect to x, differentiation of sin inverse x with respect to x equals to dt by dx. So 1 upon under root of 1 minus x square dx equals to dt. It was 1, this was 2, and this was the third. Putting 2 and 3 in 1, so we get I equals to sin inverse x nothing but t, so it is a t raised to 5, and 1 upon under root of 1 minus x square dx, that is equals to t from equation 3. Now integration of t raised to 5 nothing but t raised to 6 upon 6. But what is t value? T value nothing but sin inverse x, so it is sin inverse x whole raised to 6 upon 6. So plus c. This is required solution. Evaluate integration of sec raised to 9x upon cosec x with respect to x. Here the derivative of sec x not equal to 1 upon cosec x, and derivative of cosec x not equal to sec raised to 9x. So what to do? So can you go for substitution method? Directly you cannot go. First you have to do a little operation here, that is convert into sin and cos, because sec and cosec can be easily converted to sin and, so sin and cos. Sec raised to 9x can be written as 1 upon cos raised to 9x, and 1 upon cosec x can be written as sin x. So therefore integration of sec raised to 9x upon cosec x with respect to x can be written as sin x upon cos raised to 9x with respect to x. Now the derivative of cos x is nothing but minus sin x. Now easily can be solved. Now it has become quite easy question. So given question as a 1, let cos x equals to t. As soon as you put t, we have to do derivative, differentiating with respect to x. So differentiation of cos x with respect to x equals to dt by dx, that is equals to minus sin x dx equals to dt. So this was the second, and it was the third one. After that, I equals to, the given question can be written as sin x into 1 upon cos raised to 9x dx, which can be more further easy way can be written as cos raised to 9x into sin x dx. Both the ways you can write. Now here is sin x dx, so minus is not there. So here in equation 3 we are taking minus to that side, so it becomes minus dt. Therefore I equals to, here the cos x nothing but t, therefore it is a t raised to 9, and sin x ds equals to minus dt. Minus is taken outside, and 1 upon t raised to 9 can be written as t raised to minus 9 t. The integration of t raised to minus 9 nothing but t raised to minus 9 plus 1 upon minus 9 plus 1, that is equals to minus t raised to minus 8 upon minus 8. This minus gone, and this becomes 1 upon 8 t raised to 8. Therefore I equals to, what was the t? T was nothing but cos x. So we are back substitution. t nothing but cos x. Therefore, I equals to 1 upon 8 cos x raised to 8, that is equals to 1 upon 8 into 1 upon cos raised to 8x, that is equals to sec raised to 8x upon 8 plus c. This is required solution. Evaluate integration of 2x plus 5 upon x square plus 5x whole square. It is a clear indication that denominator is equals to t, because derivative of x square is 2x and derivative of 5x is 5. So let x square plus 5x equals to t. Call it equation number 2. Now differentiating with respect to x. So differentiation of x square plus 5x with respect to x equals to dt by dx. Derivative of x square is 2x, derivative of 5x is 5, equals to dt by dx. Therefore, 2x plus 5 dx equals to dt. Call it number 3. Now given question can be written as I equals to 1 upon x square plus 5x whole square into 2x plus 5 dx. It can be written like this. Now from 2 and 3, 1 becomes x square plus 5x is equals to t, therefore it becomes t square, and 2x plus 5 dx is equals to dt. This can be written as integration of t raised to minus 2 dt. So I equals to t raised to minus 2 plus 1 upon minus 2 plus 1 plus c, which is nothing but minus 1 upon t plus c. Now but t, what is the t? T nothing but x square plus 5. So minus 1 upon x square plus 5x plus c. This is required solution. Evaluate integration of 1 upon x log 2x log of log 2x dx. My God, all are log. Can you go for substitution? Can you go for substitution? Please answer. Yes, we can go for substitution because the derivative of log is 1 upon. Therefore, we can let here log of log 2x equals to t. It was 1 and this is 2. Now differentiating with respect to x. So differentiation of log 2x with respect to x equals to dt by dx. Now the derivative of log 2x nothing but 1 upon log 2x into differentiation of log 2x with respect to x. Here I have applied chain rule. Therefore 1 upon log 2x and derivative of log 2x is nothing but 1 upon 2x into 2 get cancelled is equals to dt by dx. Therefore 1 upon x log 2x dx equals to dt. Now given question can be written as I equals to integration of 1 upon x log 2x into 1 upon log of log 2x with respect to x. And for beginners, I write this step once again. 1 upon log 2x into 1 upon x log 2x dx. Now from equation 2 and 3, 1 upon x log 2x dx equals to dt, and 1 upon log 2x equals to t from equation 2. Therefore from 2 and 3 it becomes 1 upon t dt. Integration of 1 upon t nothing but log of mod t plus c. But what is t? What is t? T nothing but log of log 2x. Therefore, the result become of log of log 2x plus c. This is required solution. Question number 12. Evaluate integration of x raised to n minus 1 upon cube root of 1 plus 4x raised to n with respect to x. So call it as a equation 1. Now let 1 plus 4 x raised to n equals to t. Why? Because derivative of x raised to n is x raised to n minus 1. Now differentiating with respect to x. So derivative of 1 plus 4 x raised to n with respect to x equals to dt by dx. So derivative of 1 is 0, 4 as it is, and derivative of x raised to n is nothing but n into x raised to n minus 1 equals to dt by dx. Therefore, x raised to n minus 1 dx equals to 1 upon 4 and dt. Call it as a 3 number and it was a 2. From 1 and 2, given question becomes 1 upon 1 plus 4x raised to n, and if I remove the root, because nth root of p can be written as p raised to 1 upon n. Therefore, this can be written as cube root of this can be written as raised to 1 upon 3 and x raised to n minus 1 dx. From 2 and 3, this becomes t raised to 1 by 3 and x raised to n minus 1 dx is nothing but 1 upon 4 and dt. This can be written as integration t raised to minus 1 by 3 and 1 upon 4 n is outside and integration dt. After that I equals to 1 upon 4 n as it is, integration of t raised to minus 1 by 3 nothing but t raised to minus 1 by 3 plus 1 upon minus 1 by 3 plus 1 plus c. Now only the simplification is left, 1 upon 4 n 3 upon 2 into t raised to 2 by 3. What is t value? T value nothing but 1 plus 4 x raised to n. Therefore 1 upon 8n here and 3 comes here. So 3 upon 8n, and the value of t we put here 1 plus 4x raised to n and whole power plus c. This is required solution. Evaluate integration of e raised to x log sin x upon tan of e raised to x dx. Solution. Of course, here we are going to put log of sine e raised to x equals to t. What is the reason? Because it will give us the denominator. So now differentiating with respect to x. So differentiation of log of sine e raised to x with respect to x equals to dt by dx. So that is equals to 1 upon sine e raised to x into differentiation of sine e raised to x with respect to x equals to dt by dx, that is equals to 1 upon sine e raised to x, and derivative of sine e raised to x nothing but cos e raised to x into differentiation of e raised to x with respect to x equals to dt by dx. Here I have done derivative by using chain rule. Now cot e raised to x into e raised to x, e raised to x derivative e raised to x equals to dt by dx. Now this can be written as e raised to x upon tan of e raised to x dx equals to dt, call it 3. After that, now the given question can be written as I equals to integration of log of sine e raised to x as the one part and e raised to x upon tan of e raised to x dx. From 2 and 3, this is nothing but t, and this part nothing but equals to dt. Therefore, I equals to integration of t is a t square by 2. What is t here? T nothing but log of sine of e raised to x upon 2 plus t. This is required solution. Evaluate integration of 3x square upon x raised to 6 plus 2 square with respect to x. So here we can modify denominator little, that is x raised to 6 can be written as x cube whole square plus 2 square with respect to x. Let x cube equals to t, derivative of x cube with respect to x equals to dt by dx, that is equals to 3x square dx equals to dt. Call it 2, call it 3, call it 2 and call it as a 1. Therefore, I equals to, the given question can be written as 1 upon x cube whole square plus 2 square into 3x square dx. From 2 and 3, I equals to 1 upon t square plus 2 square with respect to x, with respect to t. Now formula integration of 1 upon x square plus a square with respect to x equals to 1 upon a tan inverse of x upon a. Therefore the solution, solution is 1 upon 2 tan inverse of t upon 2, 1 upon 2 tan inverse of, what is a t? T nothing but x cube. So x cube upon 2 plus c. This is required solution. Next example, integration of sec x into tan x upon sec x whole square minus 3 square with respect to x. Solution, call it as equation 1. Now let sec x equals to t. It is clear cut problem, very simple. And let sec x equals to t, derivative of sec x with respect to x equals to dt by dx. So derivative of sec x is nothing but sec x into tan x equals to dt by dx. Therefore sec x into tan x dx equals to dt. So this was the 2 and it was the 3. Therefore given question becomes, rewriting, this is nothing but sec x whole square minus 3 square into sec x into tan x dx. Now from 2 and 3, I equals to 1 upon sec x nothing but t, so t square minus 3 square integration, and sec x tan x dx is equals to dt. Now we apply the formula integration of x square minus a square with respect to x equals to 1 upon 2a log of modulus x minus a upon x plus a plus c. Therefore integration of 1 upon t square minus 3 square with respect to t equals to 1 upon 2a, a nothing but 3. So log of modulus x, in place of x we have the t, so t minus a, that is a nothing but 3 upon t plus 3. What is the t? T nothing but sec x, so 1 upon 6 log of sec x minus 3 upon sec x plus 3 mod of sec x minus 3 upon sec x plus 3 plus c. This is required solution. Example 15, evaluate sine integration of sine 2x upon p square sin square x plus q square cos square x with respect to x. Here we know that derivative of sin square x gives sin 2x and derivative of cos square x also gives sin 2x. Therefore, it is clear cut that we can keep denominator as a t. So let p square sin square x plus q square cos square x equals to t. Now differentiating with respect to x. So it is 2, it is 1. Now differentiating with respect to x. So derivative of p square sin square x plus q square cos square x with respect to x equals to dt by dx. This is nothing but p square. Derivative of sin square x nothing but 2 sin x into cos x. Here I applied chain rule. Derivative of q square nothing but q square as it is. Derivative of cos square x is nothing but 2 cos x into minus sin x. Here also I applied the chain rule, dt by dx. So here p square, here 2 sin x into cos x, here minus 2 minus q square into 2 sin x into cos x equals to dt by dx. So p square into sin 2x minus q square into sin 2x equals to dt by dx. Now sin 2x can be taken common. Sin 2x can be taken common. So we get p square minus q square equals to dt by dx. Therefore, sin 2x dx is equals to dt upon p square minus q square, call it 3. Now, after that, the given question can be written as I equals to 1 upon p square sin square x plus q square cos square x into sin 2x dx. From 2 and 3, I equals to 1 upon t and dt, that is nothing but integration of 1 upon t log of modulus t plus c. What is t value? T value nothing but p square sin square x plus q square cos square x mod is closed plus c. This is required solution. Next example, evaluate integration of x into cos of x square into root of sin cube of x square with respect to x. It is also clear cut problem because derivative of sin is cos and derivative of x square is x. Therefore, let sin of x square equals to t. This was the 1 and this is the 2. Now differentiating with respect to x. So differentiation of sin of x square with respect to x equals to dt by dx. Derivative of sin of x square nothing but cos of x square into derivative of x square is nothing but 2x. Here I have applied chain rule. So therefore x into cos of x square with respect to x equals to dt, call it 3. Now I equals to we can write the given question as here sin cube of x square into x cos of x square with respect to x. I equals to integration and this nothing but becomes t cube. This becomes t cube and the second part becomes dt from equation 2 and 3. So I equals to t raised to 3 by 2 integration of integration of 3 raised to 3 by 2 dt. So that is equals to t raised to 3 by 2 plus 1 upon 3 by 2 plus 1. So this is equals to t raised to 5 by 2 upon 5 by 2 equals to 2 upon 5 t raised to 5 by 2. Therefore, I equals to 2 upon 5. And what is the t value? T nothing but sine of x square whole raised to 5 by 2 plus c. This is required answer. Evaluate integration of x square plus 2 upon x square plus 1 3 raised to x plus tan inverse x with respect to x. This is example number 17. Now here let x plus tan inverse x equals to t, differentiating with respect to x. So differentiation of x plus tan inverse x with respect to x equals to dt by dx. This becomes 1 plus 1 upon 1 plus x square equals to dt by dx, which is nothing but equals to x square plus 2 upon x square plus 1 into dx equals to dt. So call it as a 1, call it as a 2, and call it as a 3. After that, I equals to given question can be written as 3 raised to x plus tan inverse x into x square plus 2 upon x square plus 1 dx. So I from equation 2 and 3, this becomes 3 raised to t, and this becomes dt. So integration of a raised to x with respect to x nothing but a raised to x upon log a plus c. Therefore integration of 3 raised to t with respect to t nothing but 3 raised to t upon log 3. So what is the t value? T value nothing but x plus tan inverse x upon log 3 plus c. This is required solution. Example 18, evaluate integration of 2x upon under root of x raised to 4 minus 3 square with respect to x. Here x raised to 4 is given, which can be written as x square, and derivative of x square is 2x. Therefore given problem can be written as I equals to 2x upon under root of x square whole square minus 3 square with respect to x. Call it as equation 1. Now let x square equals to t. So derivative is nothing but 2x dx equals to dt. Call it equation 2. Therefore I can be written as 1 upon under root of x square whole square minus 3 square into 2x dx. From 2 and 3, it becomes 1 upon under root of t square minus 3 square, and this becomes dt. And we know that 1 upon under root of x square minus a square with respect to x. Integration of 1 upon under root of x square minus a square with respect to x nothing but log of modulus of x plus under root of x square minus a square plus c. Therefore integration of under root of 1 minus t square minus 3 square, 1 upon under root of t square minus 3 square with respect to t is equals to log of t plus under root of t square minus 3 square modulus plus c. What is t value? T value nothing but x square. Therefore x square under root of x square whole square minus 3 square modulus is over plus c. This is equals to log of modulus x square plus x raised to 4 minus 3 square mod is over plus c. This is required result. Example number 19. Evaluate integration of 5 sec x upon log of sec x plus tan x with respect to x. Solution. Let log of sec x plus tan x equals to t. Now we apply the chain rule. Derivative of log is 1 upon sec x plus tan x. Again derivative of sec x is nothing but sec x into tan x, and derivative of tan x is nothing but sec square x equals to dt by dx. I have done directly here. I hope you got it. Now sec x is common. Here is a tan x plus sec x upon sec x plus tan x. This and this are same, cancelled. That is equals to dt by dx. Therefore, sec x dx equals to dt. It was 1. It was 1. This was 2. And this is the third one. Now I equals to 5 is there. Take it outside. It is a constant. Now it can be written as 1 upon log sec x plus tan x, and here sec x as it is, and here is the dx. Therefore I equals to 5 as it is. This is 1 upon t. Sec x dx equal to dt. So I equals to 5 log of mod t plus c. What is t value? What is t value? The t value nothing but 5 log t value nothing but log of sec x plus tan x mod is over plus c. This is required solution. Example 20. Evaluate integration of e raised to x minus 1 plus x raised to e minus 1 upon e raised to x plus x raised to e with respect to x. Let e raised to x plus x raised to e equals to t. Now derivative of e raised to x is e raised to x, and the derivative of x raised to e nothing but e x raised to e minus 1 equals to dt by dx. Now taking e common, so e raised to x upon e plus x raised to e minus 1 equals to dt by dx. So e into e raised to x minus 1 plus x raised to e minus 1 equals to dt by dx. Therefore, e x raised to minus 1 x raised to e minus 1 dx equals to dt upon e. Therefore, given question can be written as 1 upon e raised to x plus x raised to e into e raised to x minus 1 plus x raised to e minus 1 dx. From 2 and 3, I equals to 1 upon t into dt upon e, that is equals to 1 upon e integration of 1 upon e dt, that is equals to 1 upon e log of modulus t. But what is t here? But what is t? T nothing but e raised to x plus x raised to e plus c. This is required solution. Now this is the last example. Example number 21. Evaluate integration of 1 upon under root of 1 minus x square 6 plus 7 cos inverse x. Now 6 plus 7 cos inverse x equals to t. Derivative nothing but gives us minus 1 upon under root of 1 minus x square dx equals to dt. Therefore I equals to 1 upon t 1 upon t and minus dt, that is equals to log of mod t and minus here this is nothing but log of mod of 1 upon t. So this is equals to log of 1 upon t, that is 6 plus 7 cos inverse x mod is close plus c. This is required solution. Whatever I have solved here, it is nothing but drop in the ocean. I would like to solve more and more questions, but due to the time constraint, I had to stop here. Are you really benefited by this video? Please tell me. Please give me your feedback through the email address provided in the description box. Meet you again with another topic, with another video. Till then, wish you good luck. Before saying goodbye, I would like to request you like, share and subscribe the channel and share with your friends. Wish you good luck. All the best.